Okay, so hello people. So today we will be solving LeetCode daily question 1287, that is element appearing more than 25% in sorted array. Okay, so we are given an integer array sorted in non-decreasing order, and there is exactly one integer that in the array that occurs more than 25% of the time, and we have to return that particular integer. Okay, so here more than 25%, it means basically more like if we are having length array of length 10, the element has to be appearing 5 times. That is more than 25%, because 25% of 10 is 4. Okay, 25%. Okay, so the element should be appearing 5 times, or I guess equivalent to 4 will also work. Okay, so yeah, it should occur 4 times or 5 times. Like in this case, we are having that the number is occurring 1, 2, 3, 4 times. Okay, so the output is 6, and similarly in this case 1 and 1, the output is 1, because the 1/4 comes out to be 2 length 0.15. So 0.5 is not like one element only, so in this we'll be considering the 1. Okay, so this is pretty a straightforward question if you do it using hash map, but as we are given and you can all try it on your own, so by using a hash map. Okay, but in this video we'll be approaching it to using a binary search, because as we are given a sorted array, so why not to apply a binary search. Okay, so firstly what we'll be doing, we'll be setting up three boundaries. Okay, we'll be setting up three boundaries. The boundaries would be if the array element is appearing more than 25%, that is appearing means 1/4 times, so it should be appearing in between the intervals, that is n/4 and n/2 and 3n/4. So these will be the three intervals in which the element will be occurring, and these here n is the length of the array. Okay, so these will be three, and we'll be traversing using these three intervals and the elements which are present at these three intervals. Okay, so now let's move towards the coding window, and firstly let's have a variable n that is equal to length of the array. Okay, then what we'll be doing, let's have the positions. Okay, let's have the positions array, and that will be equal to element at yeah, n/4, and then element at n/2, and then element at 3 into n/4. Okay, so these are the three intervals where the element will be occurring. So what we'll be doing, we'll be traversing in the positions array int position n positions. Okay, so the element just a spelling mistake. So the element that will be appearing at these three positions could be the only element that will be occurring more than 25% of the time. Okay, so firstly what we'll be doing, we'll be calculating the lower bound of that particular this number. Okay, ARR n/4, the element which is present at n/4th position. Let's have a function, let's say lower bound. Okay, lower bound, and here we'll be passing the array and my position of that particular element. Okay, then what we'll be doing, I'll be calculating the right bound. Similarly, right bound means meaning that when is the time when the element is appearing, so that will be ARR comma position, the right bound of that particular element. And then I don't know why I'm making such a silly mistake. Yeah, and then what I'll be doing, I'll be checking that if my length is left plus 1 is greater than okay, sorry, here I forgot what is my target element. That is, let's have a target that will be equal to n/4. Okay, we are considering that it is present here, and here also we'll be subtracting -1 because to make it zero based. Okay, so we'll be checking that if length of that particular is greater than the target, So then what I'll be doing, I'll be just returning that particular element. Return position. Position here means the element which is present at that particular position, and if we don't find anything, we'll be just simply returning -1. So now let's have the method that is private int lower bound, and here we are having two arguments, that is array and the target, or let's say element. Okay, element. Then we are using 2 pointers for the finding the lower bound, and right will be equal to arr dot length -1. Okay, then simply while left is less than right, what I'll be doing, I'll be calculating the mid, that is equal to left plus right minus left by 2. Okay, you can also simply do left plus right by 2, but this is just a case to handle the overflow condition. Okay, and then I'll be checking that if my array mid is greater than the element we are looking for, I'll be setting my right equal to mid, and else what I'll be doing, I'll be moving my left equal to mid plus 1, and at the end just simply return left. Okay. So what I'll be doing, I'll be just copying this, and I'll be making small modifications for the finding the right bound or the upper bound. Okay, let's call this also upper bound. Okay, upper bound. So let's copy this. So I'll be simply copying this and pasting it, and naming, firstly let's name it to upper bound, and similarly left equal to 0, right equal to length of the array. Oh, okay, here we'll be doing length of the array, as here it was array length of the array. Okay, here also length of the array. Okay, because here the condition is left is less than right. Okay, so after that similarly in both the cases I just have to return the left, and while left is less than right, and mid is equal to left plus, yeah, while int left and mid is equal to left plus right minus 2, and here just a small change, that here it will be equal to. Okay, if array mid is greater than or equal to element, I'll be setting my right equal to mid. Okay, sorry, not here, in the lower bound condition. Okay, the right is equal to mid and left is equal to mid plus 1. Okay, so now let's run it, and this would be enough. Okay, it says compiler positions. Okay, not positions, I guess. Yeah, position. And now let's run it, and it gets accepted. Okay, so now let's submit it, and it works perfectly well. Okay, so this was it for today. Thank you for watching.